The GHD Sit-Up Movement Analysis by Alex Witter, Nathan Lozano, and Nicole Shattuck. The GHD sit-up is performed on the glute ham developer. It is also known as the Roman chair sit-up.
This is the GHD sit-up.
In performing the GHD sit-up, the athlete starts at 90 degrees of flexion at the coxal joint, with legs parallel to the ground, feet anchored, and torso braced. The athlete then goes through a controlled extension at the hips while maintaining a brace through the torso, stops at parallel, and then reverses the motion to return back to the starting position. The CrossFit community has made the GHD sit-up popular by making a dynamic move under load, and athletes are encouraged to hyperextend from their lumbar and thoracic spine in order to reach their hands to the ground. Unfortunately, this puts an incredible amount of shearing and compressive forces on the spine and low back. It is not advised. The relevant joints involved in the GHD sit-up include the thoracic spine, lumbar spine, as well as the coxal or hip joint and the talocrural or ankle joint. The coxal joint will be in either flexion or extension, while the thoracic spine and lumbar spine will maintain their neutral position. Talocrural will stay in dorsiflexion. This is an image of a seated supine sit-up, and although it is not exactly the same as a GHD sit-up, for the purposes of our joint positions, it is very similar. The starting position, the person will be seated. They'll be at flexion at the coxal joint and the femoral acetabular joint, about 90 degrees. The thoracic and lumbar spine should remain neutral and maintain the natural curvature. In the downward phase of the GHD sit-up, the muscles will be in an eccentric phase. The coxal and femoral acetabular joint will be moving through extension. Thoracic and lumbar spine will again maintain their natural curvature. The sticking point of the GHD sit-up does not involve any support on the low back or torso. The coxal joint and femoral acetabular joint will be extended to 0 degrees. The thoracic and lumbar spine again maintain their natural curvature, but gravity continues to act on the torso. In the upward phase of the GHD sit-up, the coxal joint and femoral acetabular joint will experience flexion, while the thoracic and lumbar spine again maintain the integrity of their natural curvature. This will be the concentric phase for the primary movers. Ideally, a GHD sit-up limits the amount of lumbar flexion. Therefore, the tension is focused on the external obliques, rectus abdominis, and transverse abdominis. And this was seen in a study by Sullivan, Garden, Bellin, and Lee as they compared the EMG response of the rectus abdominis, external obliques, rectus femoris muscles, as well as the trunk and hip kinematics during a straight leg and bent knee sit-up. Although many believe that the GHD sit-up is a core or ab exercise, the primary muscle contractions are actually seen in the iliopsoas and rectus femoris. Secondary muscles of the GHD sit-up include the vastus lateralis, vastus medialis, rectus abdominis, external obliques, transverse abdominis, tibialis anterior, and the peroneal tertius. Those muscles that are secondary to the movement tend to be isometric. Although they will receive forces of gravity that they must overcome, they are not primary movers. In a study by Cordo et al., 2003, the sit-up was evaluated in 2 different parts, the trunk curling and the footward pelvic rotation, which is when the pelvis begins to rotate towards the feet. During the trunk curling, the pelvis rotates towards the head rather than towards the feet, which eliminates lordosis and flattening of the lumbar trunk on the support surface. We see in that for the GHD sit-up, The stability of an individual while sitting up depends on maintaining the adequate separation between the trunk axis of rotation and the center of gravity. The magnitude of separation influences the static torque on the portion of the body that remains in contact with the support surface. Therefore, the greater the static torque on the body in contact with the support surface, the better leverage on the part of the body that's being lifted. Newton's first law, the law of inertia, dictates that objects in motion or at rest will stay in motion or at rest unless acted upon by an outside force. And with a GHD sit-up, we know that because of the third class lever, the muscles are at a mechanical disadvantage in order to combat the pull of gravity, rotational forces, to return the person to their seated 90 degrees of flexion start position. Newton's second law explains that in order to accelerate or decelerate, a force must be applied. As we look at force as a product of mass times acceleration, we can see that the greater the force that's generated, the greater the acceleration or deceleration needs to be. And for those muscles to counteract the forces of gravity and mass in order to return the person to starting position. Newton's third law dictates that for every action, there's an equal and opposite reaction. So the forces of gravity and rotational forces that are acting on the upper body must therefore be counteracted by the torque of the lower body during the GHD sit-up. So a person's height, mass, and the speed of their movement will all be taken into account. So if an athlete is not as strong, we may need to limit their range of motion if they're not able to maintain their posture and position in the GHD sit-up. In conclusion, the GHD sit-up is an effective movement so long as the person is performing with proper form. The position, velocity, and acceleration of the GHD sit-up is dependent on the height of the person, the speed at which they're performing the movement, and their mass.